Welcome to the demo for 8.2, calculating the sample size. We're going to do this by hand and using Minitab. So suppose that we collected the weights of fun-size packs of M&Ms and have recorded them in an Excel file. We're going to actually take that Excel file and put it into Minitab. Let's calculate and interpret the 95% confidence interval for the true weight of a fun-size bag of M&Ms. We're also going to determine what the margin of error is on this confidence interval. In Minitab, to calculate the confidence interval, we go to Stat, Basic Statistics, 1 sample T. When the dialog box comes up, we're going to punch our variable net. This is the net weight of a fun-size pack of M&Ms. Be sure to set the correct level of confidence in the Options button. Once we do that, we hit OK again, and we get the confidence interval. This actually tells us that we can be 95% sure that the true average weight of a fun-size pack of M&Ms is between 12.645 grams and 13.555 grams. Now, that's actually a pretty broad range. That's almost a full gram. Let's look at what the margin of error is here. So I'm going to call the margin of error MO. From the confidence interval, we can actually calculate MO by taking the upper bound, subtracting out that sample average, and that distance will actually be MO. Remember, a confidence interval is calculated by taking the sample value, going down 1 MO and getting that lower bound, going up 1 MO and getting the upper bound. So MO is really upper bound minus mean. We could also do mean minus the lower bound, or we could do upper bound minus lower bound divide by 2, because there are 2 margin of errors between the lower bound and the upper bound. In other words, the confidence interval is 2 margin of errors wide. From our output in Minitab, the easiest way to find MO is to take the upper bound and subtract the mean. So 13.555 minus 13.100. Our margin of error is plus or minus 0.455 grams. Now, that's actually pretty wide. When you have an average that's only around 13-ish grams, that's a fairly large margin of error. That's actually about a half of an M&M's weight in margin of error. Suppose that we want to determine the sample size necessary to still create that 95% confidence interval, but we want the MO, or the margin of error, to be plus or minus 0.1. So that's much smaller margin of error than what we calculated so far. We need to know what N is. What is the sample size we need to have? In other words, how many packages of M&Ms do we need to weigh? The formula to calculate the sample size necessary to meet our confidence goal and our margin of error goal is N equals Z squared, which is our critical value, and then we square it, the standard deviation of our data squared, and then MO gets squared on the bottom here. So Z squared, standard deviation squared, divide by MO squared. To be able to calculate our N, we need to know some estimate of that standard deviation. In reality, we usually won't have sigma, so we'll need to find S. Remember, S is our sample standard deviation. We could find this by running descriptive statistics, but we can also go back and look at our Minitab output from running the confidence interval. The sample standard deviation will be included in that output. In our Minitab output, this value here is our sample standard deviation, or S. We can use this value S in place of sigma to calculate our required sample size. So we've got this desire to have a 95% confidence level. We want our MO to be plus or minus 0.1, and we know that our sample standard deviation was 1.053. So Z is 1.96. Remember that 1.96 is the Z critical value associated with a 95% confidence interval. You can look it up in the table, or you can use norm.s.inv of half of 5%, and then of course take the absolute value. 95% is in the middle, 5% would be in the 2 tails. We divide 5% by 2 to look at just 1 tail. Norm inverse of 2.5% is 1.96. So 1.96 squared times 1.053 squared divided by 0.1 squared. So if you work out the math on this, you should get something around 425.96. This means we need to sample 426 fun size packs. We always round up. I didn't round up here simply because I learned back in the day that you should round up if you're 0.5 or beyond in the decimal place. We always round up. So if this had been 425.4, we still would have rounded up to 426. Now, 426 fun-size packs is what we need to sample. However, we've already weighed 23 packs. This data is useful data, so we don't need to throw it out. We can continue to use it. So we really only need to weigh 403 more fun-size packs. Remember, as long as the data is being sampled from the same population, we don't have to throw away the information we collected from that pilot sample. Now, if we were to want to let Minitab do this for us, we could go to Stat, Power and Sample Size. Notice that sample size is in there. And then go to the very first option there that says Sample Size for Estimation. That's going to be the thing that allows us to directly calculate the sample size. The dialog box for sample size for estimation is on the left. You'll see it's selected to mean automatically. Don't change that. We want to leave it mean normal. Enter in your standard deviation value, so 1.053 went in here. This should automatically be set to estimate the sample size. If it's not, please make sure to set it for that. And then in this box, you enter in your MO. What is the target margin of error that you're looking for? Also, you'll want to click in the options box and make sure that you've got the correct level of confidence. Also, we're going to assume that we're looking at large sample sizes, so make sure to check this box here that says assume the population standard deviation is known. In other words, use a Z in the calculation instead of a T. Hit OK and hit OK again, and we'll get our output. You'll notice that Minitab gave us the same 426 fun size packs that we calculated when we did this by hand. So I say use the best tool for the job and use Minitab. Thanks so much, and I'll see you again soon.